Hello, we are here for one more lesson of this T-FLEX analysis training course, and the topic for today will be a brief description of the different types of finite element modules. This first interaction with the software, it's what we call the preprocessor, and its main purpose is to prepare this initial data for the physical study that we are going to run with all the goals that we mentioned in the previous lesson. Among these data that are needed to have the preprocessor ready to run the study, we have this finite element mesh, the materials data, and the initial and boundary conditions of this physical study. One of the topics that is very important to consider this initial preparation, it's the type of models that we have. We will see along these video lessons different characteristics that we can give to the system to create the mesh, but a brief description to prepare you for this information. We have three kinds of finite element modules. We have the first one that we call the tetrahedral finite element module, and basically it's for something like this, or we can say that it's a general part, and this is the case where we approximate the geometry to the model part. We use these tetrahedral shapes of the finite elements to represent the model in terms of the analysis. And this tetrahedral mesh approximates complex shapes of parts and can give you very satisfactory results of the modeling of these physical studies. And you can run any arbitrary shape. We can consider this type of model. It has a lot of different parameters that we can set, and we will see that on the lessons that will follow. But basically, we can identify this kind of finite element module if all the three space dimensions, the length, the width, and the height, are not very much different from one another. Okay, so most of the parts and joints, this big group. Okay, so no particular item to consider. Then we have another type of model that we call the laminar finite element module, and I've opened this module here. This particular case, it's an example that intends to calculate a study of cylindrical reservoir. And these laminar modules, it's a subclass of structures that are used in people's life as a special geometric shape, where one of the dimensions, usually the thickness, is considerably smaller than the two other dimensions, as you can see for this example. So we have dimensions that are no particular defined, but we have a very thin thickness, and this is the characteristic that differentiates this kind of model from the previous one. Examples of these, we have shells of machines, spirals of turbines, elastic elements, membranes, whatever, a lot of things. Okay, so we will see also examples of this kind of models. For these laminar modules, instead of tetrahedral, it is possible to use laminar finite elements that allow the user to obtain a satisfactory solution with smaller computational effort than using the 3D finite element way. Okay. Uh, then, as the third type of object, we have what we can call a hybrid finite element module, and this kind of element includes a mix of the tetrahedral and the laminar one. So we have parts that have both kinds of geometries inside. So nothing more particular to differentiate this kind of hybrid type of part. So these were the topics to mention in this lesson of T-FLEX. Very shortly we will start also to release examples of different kinds of modules and different kinds of calculations possible to use in the software. So all of these things that we are talking about in these lessons will be shown in practice. Anyway, any questions that you may need, so you can give us an email or a contact, and we will here for supporting you in your questions.